In finance, the rule of 72, the rule of 70 and the rule of 69 are methods for estimating an investment's doubling time. The rule number is divided by the interest percentage per period to obtain the approximate number of periods required for doubling. Although scientific calculators and spreadsheet programs have functions to find the accurate doubling time, the rules are useful for mental calculations and when only a basic calculator is available. These rules apply to exponential growth and are therefore used for compound interest as opposed to simple interest calculations. They can also be used for decay to obtain a halving time. The choice of number is mostly a matter of preference. 69 is more accurate for continuous compounding, while 72 works well in common interest situations and is more easily divisible. There are a number of variations to the rules that improve accuracy. For periodic compounding, the exact doubling time for an interest rate of a per period is, where t is the number of periods required. The formula above can be used for more than calculating the doubling time. If you want to know the tripling time, for example, simply replace the constant 2 in the numerator with 3. As another example, if you want to know the number of periods it takes for the initial value to rise by 50%, replace the constant 2 with 1.5. Using the rule to estimate compounding periods, to estimate the number of periods required to double an original investment, divide the most convenient rule quantity by the expected growth rate, expressed as a percentage. For instance, if you were to invest $100 with compounding interest at a rate of 9% per annum, the rule of 72 gives 72 ninths equals 8 years required for the investment to be worth $200. An exact calculation gives ln 2/ln 1 plus 0.09 equals 8.0432 years. Similarly, to determine the time it takes for the value of money to halve at a given rate, divide the rule quantity by that rate. To determine the time for money's buying power to halve, financiers simply divide the rule quantity by the inflation rate. Thus at 3.5% inflation using the rule of 70, it should take approximately 70/3.5 equals 20 years for the value of a unit of currency to halve. To estimate the impact of additional fees on financial policies, divide 72 by the fee. For example, if the universal life policy charges a 3% fee over and above the cost of the underlying investment fund, then the total account value will be cut to 1/2 in 72 March equals 24 years, and then to just 1/4 the value in 48 years, compared to holding exactly the same investment outside the policy. Choice of rule. The value 72 is a convenient choice of numerator, since it has many small divisors, 1, 2, 3, 4, 6, 8, 9, and 12. It provides a good approximation for annual compounding, and for compounding at typical rates. The approximations are less accurate at higher interest rates. For continuous compounding, 69 gives accurate results for any rate. This is because ln 2 is about 69.3%. See derivation below. Since daily compounding is close enough to continuous compounding, for most purposes 69, 69.3 or 70 are better than 72 for daily compounding. For lower annual rates than those above, 69.3 would also be more accurate than 72. History. An early reference to the rule is in the Summa di Arithmetica of Luca Pacioli. He presents the rule in a discussion regarding the estimation of the doubling time of an investment, but does not derive or explain the rule, and it is thus assumed that the rule predates Pacioli by some time. Roughly translated, adjustments for higher accuracy, for higher rates, a bigger numerator would be better. This is because, as above, the rule of 72 is only an approximation that is accurate for interest rates from 6% to 10%. Outside that range the error will vary from 2.4% to a 14.0%. For every 3 percentage points away from 8% the value 72 could be adjusted by 1. Or for the same result, but simpler. EM rule. The Eckart-Michael second-order rule, the EM rule, provides a multiplicative correction for the rule of 69.3 that is very accurate for rates from 0% to 20%. the rule of 69.3 is normally only accurate at the lowest end of interest rates, from 0% to about 5%. To compute the EM approximation, simply multiply the rule of 69.3 result by 200/200R, as follows. For example, if the interest rate is 18%, the rule of 69.3 says T equals 3.85 years. The EM rule multiplies this by 200 over opening round bracket 200 minus 18, giving a doubling time of 4.23 years, where the actual doubling time at this rate is 4.19 years. Note that if the numerator here is simply 69.3 times 200. As long as the product stays constant, the factors can be modified arbitrarily. The EM rule could thus be written also as, or, in order to keep the product mostly unchanged. In these variants, the multiplicative correction becomes 1 respectively for R equals 2 and R equals 8, the values for which the rule of 70 is most precise. Similarly, the third-order Parda copyright approximate gives a more accurate answer over an even larger range of R, but it has a slightly more complicated formula. Other rules, extending the rule of 72 out further, other approximations can be determined for tripling and quadrupling. To estimate the time it would take to triple your money, one can use 114 instead of 72 and, for quadrupling, use 144. Derivation, periodic compounding. For periodic compounding, future value is given by, whereas the present value is the number of time periods, and stands for the interest rate per time period. The future value is double the present value when the following condition is met. This equation is easily solved for. If R is small, then ln, 1 plus R, approximately equals R. Together with the approximation, this gives, which improves in accuracy as the compounding of interest becomes continuous. However, humans tend to prefer performing mental calculations with percentages, so the formula is often restated as follows. In order to derive the more precise adjustments presented above, it is noted that is more closely approximated by, can then be further simplified by Taylor approximations. Replacing the R in R/200 on the third line with 7.79 gives 72 on the numerator. This shows that the rule of 72 is most precise for periodically composed interests around 8%. Alternatively, the EM rule is obtained if the second-order Taylor approximation is used directly. Continuous compounding. For continuous compounding, the derivation is simpler. See also, exponential growth, time value of money, interest, discount, rule of 16, references. External links. The scales of 70 euro extends the rule of 72 beyond fixed rate growth to variable rate compound growth including positive and negative rates. A note on the rule of 72 or how long it takes to double your money. The Investment Analyst Society of South Africa, Rule of 72 Calculator, MoneyShimp.com, Rule of 72 Learning Tool, DirectInvesting.com, Financial Mathematics, Excel Exchange.